Today we're going to go over two different ideas. The first is systems of equations. We're going to talk about how to graph two different equations on the same graph. We're also going to go over uh, inequalities and linear inequalities uh, for part two of our lesson today. So to start with, let's start by defining what a system of equations is, how to solve it, and we'll look at the different ways that we can solve it as well. So, what is a system of equations? It's a system of equations is just two or more equations that have two or more variables. So, just like our linear equations where we had y equals something x plus a number, um, we could have two lines that are on our graph and they make what's called a system of equations. And if we graph two lines, we want to find out where those lines cross at. So if they cross at one point, that is our solution to our set. And we'll look at an example with graphing in just a moment. But there are two other algebraic ways that we can solve systems of equations as well. Most likely for the SAT, you'll be able to graph with a graphing calculator, and you probably won't really need elimination or substitution, but I do think it's still something that's good to know. So elimination, basically what we do with elimination is we write both of our equations out, and then we try to multiply one of those equations so that we can cancel out either the x's or the y's from both equations. So I'm going to scroll down here. We're going to look at this example. And this has the example stuff written out, but I'm going to show you how I would solve this system of equations. So in this example, it looks like we need to cross out a variable. So we need to decide, do we want to get rid of the x's or the y's? It really doesn't matter. You just have to choose which one that you want to get rid of. So if you want to get rid of the x's, what you do is you decide what is a common factor of 3 and 5. And if you take a moment and think about that, if you count up by threes, 15 would be the closest. If we count up by fives, we would also get 15. So for this, what we're going to do is, I like to call this equation 1 and this equation number 2. So we want to cancel out those x's. So what we're going to do is we're going to multiply equation 1 times 5. Now, if we multiply the whole equation times 5, that means all of this times 5, and then all of this times 5. And we're allowed to do that with algebra because we can multiply by the same amount on the left and on the right, and it still makes all of our equation hold true. So we're going to multiply equation 1 times 5. And then if you remember when you did addition in elementary school, like 355 plus 240, and you add in the columns, it's kind of like that with elimination. So let's see if I can go back. So you just add columns 5, 9, 5. So same kind of idea with that with elimination. Now, if we do equation 2 times 3, that also gives us 15. But if we add those together, we would get 15x plus 15x, and that would give us 30x. We don't want 30x for our answer. We want 0x for our answer. So if we have the first equation, equation 1 times 5. That makes this 15x. That means we need to multiply this 5x by something so that it equals negative 15x. And if you read through the example here, you can see it says negative 3. So we're going to add equation 2 times negative 3. And so let's write all this out now. So 5 times everything on the left and 5 times everything on the right. So for equation 1, it's going to be 3x. Well, excuse me. I was going to write it 3x times 5, but let's just write it out because I think everybody knows how to do multiplication. So 3x times 5 is 15x. 2y times 5 is 10y equals 5 times 5 is 25. So that's our new equation 1. Sometimes when I do the new equations, I like to call them A and B, but you can still just call it equation 1. That's fine. For equation 2, we're going to do everything times negative 3. So now this is negative 15x minus 9y equals 9 times negative 3 is negative 27. And you can see that here in the example also. So if we add these columns, now these cancel out and we have no more x's left. 10y minus 9y is just 1y. And 25 minus 27 is negative 2. Now we know that y is negative 2. So now we go back, and that was kind of easy. We didn't get like a 3y or something, just told us 1y, which is great. That was our ultimate goal. But if we had something like 5y, we'd have to divide by 5 and solve for y. So this says y is negative 2, and we're going to plug that in to either one of these, this one or this one. And that's going to tell us what x is. So we can plug it back in to, let's just say equation 1. So 3x plus 2y, we know y is negative 2, so that's 2 times y, or 2 times negative 2, is equal to 5. 3x minus 4 equals 5. Going to add 4 to both sides. 3x is equal to 9. Divide by 3 on both sides. And we get x equals 3. So what does this information really tell us? Well, this says if we graph this equation 1 and graph equation 2, those two lines, they're going to cross at 3 comma negative 2. Now, this is the algebraic way to solve this. I think probably the fastest way to do this is a lot of students, they do substitution, and we'll go over that in just a minute. But let's just skip to the graphing part next. So I want to go to the graphing part to show you what this 3 negative 2 means. So I'm just going to type in equation 1 and equation 2 into Desmos. Okay. And if we zoom in, we can see that they cross at 3 negative 2. So here's the red line is equation 1, and the blue line is equation number 2. And that's a lot faster than doing the elimination method. But if you want to check your work, and if you have extra time for a problem, you can definitely use elimination. Okay. Let's go through a different topic of substitution. So substitution is if you don't want to use the elimination method and you don't want to think about, well, what do I want to cross out and what number do I have to multiply by? There's a slightly easier way to do this. A lot of students lean toward using this method, I think, especially when they didn't used to let graphing calculators be allowed for some of the problems years ago on the SAT. So For substitution, all we do is we choose equation 1 or equation 2, and then we solve for, we have to decide, do we want to solve for 1x or do we want to solve for 1y? And if we wanted to solve for what 1x is, that would probably be the easiest thing to do here. And that's what they did in this example. So you just minus 2y on both sides for equation number 1. And so now our new equation 1 says x equals negative 2y plus 5. Or they wrote 5 minus 2y. Either way is fine. Now, since we've solved for what x is for equation 1, we're going to put that value of x into the x value for equation 2. So equation 2 is going to be 3x, and we said x is negative 2y plus 5. And sometimes these can be fractions. So if you get a fraction, that doesn't mean that you got the wrong answer. And then we're going to solve for what y is. So you'd use the distributive property to continue equation 2 and get negative 6y plus 15 equals 13. Divide by negative 6 on both sides. And I'm hoping I did this correctly. I might need to double check my work here. 13. Let's see what happened here. Ah, yeah, let me go back here. I think I wrote equation 2 incorrectly. I didn't write the rest of equation 2. So equation 2, we write plus 5y. I forgot to write that 5y there. So now what happens is we get negative 6y plus 15, just like before, but now we do plus 5y equals 13. And now negative 6y plus 5y is minus y, or negative y. Subtract 15 on both sides, we get negative y equals negative 2. Divide by negative 1 on both sides, or times by negative 1 on both sides, we get y equals 2. Okay, now that we know what y is, you might have guessed it, you can plug in y for equation 1. So all of this, you just plug that in for y onto equation 1, and we will get an answer for x. So write equation 1 again. X equals negative 2 times 2 plus 5. X equals negative 4 plus 5, and x equals 1. So for these, it's going to cross at 1, 2. So that's how you do substitution. All right. So I believe that's everything for this solving by graphing. Okay, so that's systems of equations 67. Systems of equations 26 is about how many solutions there are altogether in a system of equations. And we might have talked about this earlier. We can have no solutions, one solution, or infinite solutions. So rather than going through all of these examples, because I think we've talked about this previously, I'm just going to draw out the graph and the difference between no solutions. We'll put the no solutions example here. See if we can just copy this. Say this is one solution. This will be infinite solutions. And if you remember this from previous lessons, that's awesome. So no solutions would be if we have two parallel lines. They never cross, and so we never get a solution. One solution would be just standard, where we have one line going one direction and another line going another direction, and they cross at just one point. And infinite solutions is kind of a unique one. It's the same exact line. So have a line like that. And then our second line, and I'll draw it in a different color so that we can see that it actually is overlapping, is the exact same line. So that's infinite solutions. And you've got to be careful with the infinite solutions sometimes because just by looking at the equation, sometimes it looks like two different solutions, and you might think that it has one solution, but really it can be infinite solutions. So ultimately, I would suggest graphing these on Desmos if whenever possible. That way you can just make sure that it's the same line on Desmos. So the rest of this stuff it's good information to know, but I think it's a little bit much to be memorizing for the SAT. It has to do with how we can determine slope and the amount of solutions. So one more thing about the slope and the solutions. If we have the same slope, which is that value, and here it would be this value. If we have the same slope, that means that it's going up by the same amount or down by the same amount. So that means that lines are going to be parallel with each other if it has the same slope. If it has a different y-intercept, that means that one line is going to be scooted up above one of them, and the other line is going to be below. So in this example, this would be no solutions. Now, if we had the same y-intercept and the same slope, that's just the same equation. So we would have infinite solutions. I believe that's everything that we need to cover just for how many solutions there are. There wasn't a lot of information on that part, but it does have to do with systems of equations.